All right, so in this video, we're going to look at solving general triangles, which means that I don't necessarily have a right angle, and I have to look for a different approach in order to find missing information. And in this video, we're going to focus on the application of law of sines. Now, law of sines can be used anytime you have the measure of a known angle. So I have a known angle and the measure of its opposite side. If I have that, so if I have a known angle and the measure of its opposite side, I can use law of sines. Law of sines states that there's a consistent ratio inside of a triangle, where if I take sine and apply sine to an angle and divide that by the measure of its opposite side, that ratio is going to be the same for all angles and sides inside the triangle. Now, I wrote the formula down here as sine of the angle divided by the measure of its opposite side. The reciprocal of all of those work as well. And in fact, if it's sometimes more helpful, depending on what you're solving for, but I could say the side divided by sine of the angle. And that's the same thing. So whichever way you want to use it is fine. The important thing to know is that the angle measures go inside of sine and the sides are on the opposite part of the fraction here. Okay, so now let's look at an example of using law of sines to solve a triangle, or at least for a certain part of a triangle. And so our goal here is to find side BC. Well, side BC is technically side A here. And in order to do so, I need to look at the information that's provided. Well, I have 2 out of my 3 angles inside of the triangle. I cannot use right triangle trig because there's no 90. And so we're looking, and we'd like to be able to apply law of sines, but the only side measure we know is the 6 inches, which is across from angle B. Now, angle B is very easy to solve for because I know 2 out of 3 angles in the right triangle. So let's do that. Let's go solve for angle B. So B is going to equal 180 minus 104 minus 47. And we do that, and we should get an angle measure of 29 degrees. And so I know angle B is 29. So now that I know that angle B is 29, I can set up law of sines because I have the measure of a known angle and the measure of its opposite side. So sine of 29 degrees divided by its opposite side of 6. That's got to equal, now I can take, my goal is to find A. Well, A is across from the 104 degree angle, so I would say sine of 104 degrees divided by A. All right, and then I wish to solve from here. So from here you would cross multiply, get A out of the denominator. So I'd cross multiply, and that's going to give me A times sine of 29 equals 6 times sine of 104. And then we would divide by sine of 29. And we would have A, side A is equal to 6 times sine of 104 degrees divided by sine of 29. Now, if you're at home and you don't have a calculator, if you have an Android device, you can download the Wabbit Emu emulator, and you can put pretty much any calculator you want to on that. You can get a TI-84. If you have an Apple operating system, there is a new app called Calculator X, which you can actually download for free, and the free tools have the basic stuff you would need to do most of the algebra problems. And that's what I have over here on the left-hand side of the screen. And so I'm going to work here on this calculator. Now, you got to make sure you're in the correct mode. So I'm in degree mode over here, which is where I need to be. And so I'm working here to solve 6 times sine of 104 divided by sine of 29. And that gives me approximately 12.01. All right, so there's using law of sines to solve for a particular side. Now let's look at an example where we want to find the measure of angle K. So angle K is right here. Now in this problem, we're looking and we're given the measure of angle H and its opposite side. So we don't really have to do any work right out of the gate here because we have all the information that we need to set up law of sines in this problem. We know that if we apply sine to 76 degrees according to the law of sines and divide that by 26, that ratio has to equal sine of whatever angle K is divided by its opposite side. I scrolled over too far, of 19. And then we want to work to solve from here. So from here, we would multiply to get the 19 out of the denominator. So it becomes 19 times sine of 76 degrees divided by 26 is equal to sine of K. And now to get K all by itself, I would need to apply the inverse sine function to both sides. So inverse sine of the left-hand side, 19 times sine of 76 degrees divided by 26 is going to equal inverse sine of sine of K. Now, when I apply inverse sine to regular sine, that's going to cancel the signs out because the inverse function undoes the regular function, leaves you with the end sign. So I got K equals. Now, I go here to evaluate on the left. A lot of people get in trouble. They try to type the whole thing in at once, and they forget to close a parenthesis or something. They get the wrong answer. I'm going to do 19 times sine of 76. I get that decimal. Divide that by 26. And then we're going to do inverse sine. Well, inverse sine on your calculator, you do second sine. That did regular sine. Second sine. Yep, that brings up inverse sine of that previous answer. So second answer. And then enter. And it gives me my answer here to be about 45.16, and it's an angle, so degrees. All right, so that's using law of sines to solve for an angle. Now let's use law of sines, an example of law of sines, to solve for all missing parts of a triangle. Now in this particular example, we're given the measure of angle K, which is 89 degrees. And the measure of its opposite side of 33. Don't look at it and say, oh, 89 is close to 90, so I'm just going to use right triangle trig. It'll be close enough. No, don't do that. Right triangle trig is only valid if it is a true 90-degree angle. So because it's not 90, and I have the measure of its opposite side, we're going to set up and do law of sines. So sine of 89 degrees divided by 33 is going to equal, well, my hands are tied here in terms of what to solve for next. I'd have to solve for angle Z because I have the measure of its side opposite of it, which is 28. So I'd say sine of Z divided by 28. And then I'd go solve for Z. So I'd multiply to 28 to the other side. So 28 sine of 89 divided by 33 is equal to sine of Z. And then to get my answer for Z, I would have to apply inverse sine to both sides. Which this would allow me to figure out what Z is. So 28 sine of 89 divided by 33 inverse sine of that answer. And I get z to be about 58.03. All right, so I have the measure of angle z here. Now that's the rounded version. Now let's go get the measure of angle y. So the measure of angle y, so I have 180 minus 89 minus what we got for z, 58.03, is equal to y. Now I have the 58.03 stored in my calculator, so I'm going to get a more accurate answer here by using the entire decimals on my calculator. So 180 minus 89 minus that whole decimal we got for z. And we get, and I'm rounding here, when I do this, I get y, angle y is equal to 32.97 degrees. Now, I still have that whole decimal saved in my calculator because I want to be as accurate as possible to find that opposite side. I don't want to have rounding error I don't want to round too early in my problem, because then my rounding error becomes larger the more times I use the rounded number, if that makes sense. So I'm going to go back to my original sine, law of sines ratio to solve for y, because this is not rounded. Sine of 89 divided by 33 is going to equal sine of 32.97 divided by the opposite side, y. So I'd cross multiply here. So we'd have y times sine of 89 degrees equals 33 times sine of 32.97. And then I divide by sine of 89. And that's going to give me y, which would be the last missing part of information. Now, again, we have the entire decimal of 32.97 in our calculator, so I'm not using the rounded one. So I'm going to start, I'm going to say, I'm going to go 33 sine of that answer we have for our entire decimal, and then divide that by sine of 89. And we get 17.96 for our answer. All right, so that's solving triangles using law of sines.